It's May 26th, 2021, and this is the joint food ontology work group discussion call. And we've got an agenda this morning. I'm going to start with just a item pitched to the other ontology curators, and that is OBOFoundry tagging, or just tagging of your ontology in general. So I'm going to screen share to talk about just a few things to do to get a little more exposure on the ontology side. Oops. So for those of you who host on GitHub your ontology, OBOFoundry just sent out a little notice a month ago saying you can actually add a tag to your ontology to say that it's part of the OBOFoundry group. So this is me going over to look at food on, and the way you add the tag is over in the About section. There's a little gear there. Click on it, and the topics area is where you can add the OBOFoundry keyword. And ontology, add any other topics you might want. Let's see, I guess food as well. So, and I think this may be a way to add more exposure. Certainly, the handy thing is that in OBOFoundry, they're going to list or link to this tag, and you will then be able to see all of the other ontologies on GitHub that are OBOFoundry members. So that's another place to promote. Okay, so that's all I wanted to say there. And so let's just see, is Chen on the call? Let me just get my participant list open. Chen, you are. So are you ready to?
Hello. Yes, I'm here. Can you hear me?
Yes, and I'm making you a co-host now so that you can present.
Okay, yeah, thank you so much. I will share my screen.
Great.
Yes, you can see my screen now, right?
Yep.
Okay, so first of all, thank you so much. I'm the curator of the Ontology for Nutritional Epidemiology, and this ontology has been developed since 2019, and this is the third year of the ontology. So this year we are in a project which called Systemic, and in this project we are responsible for a task regarding the annotation of food-based data guidelines. So that's why I want to give an update to ontology, because we make a few changes of the ontology, and also we do a use case based on the Ontology for Nutritional Epidemiology and also other food relevant ontology. And especially we use foodon to annotate all the food items appeared in the FAO food-based data guidelines. So I would generally describe how we did our task and how we annotate the data guidelines with the food ontology. Well, first we check the homepage of the food-based data guidelines, and we generate the list of countries, and also we extract the list of URIs of each country, because we can find, because here you can see the list of the countries, but we cannot extract the information of the specific food-based data guidelines from this page. So on this page, we also extract the URIs. we also extract the URIs. Here, the URIs of the 1995 food-based dietary guidelines. And with these URIs, we start to analyze the information appeared on this website. For instance, the name, official name, publication year, stakeholders, the messages, and the guidelines, etc., etc. Yes, and then we do some kinds of programming. We use the Bear Portal APIs, and we also use the Stanford natural language processing tools to process all the information appeared on this in the food-based dietary guidelines. And there are two parts. The first part is about the basic information of food-based dietary guidelines. For instance, the country's name, the country's name, the official name, the publication year, and also like the stakeholders, for instance, the University of Porto, the National Council for Food and Nutrition, etc., etc. Those kinds of basic information are analyzed by the Stanford NLP models. And also, we also use this model to extract the numbers and to get the target age group of each food-based dietary guidelines. So these things are about natural language processing. And at the same time, we also use ontology, like Foodon, to annotate the different food-based dietary guidelines, especially the part relevant to nutrition and food. For instance, like caffeine, like alcohol, like sugar, like water, food products. I cannot say is we do a perfect work, but we try our best, and we see most of the food items has been identified by using the food ontology. And yes, it's I think it's a quite interesting task, because we start to use the ontology, food ontology, to annotate the text, and by doing that, maybe in the future we can make the food-based dietary guidelines easier to be accessed and easier to be found. So here we use the Neo4j as the mean graph database to store these kinds of information. And you can see here are just some kind of search that's appeared here. For instance, if you want to find information about dietary guidelines about a certain country, we can type a country and find all the relevant information. And also here, if you would like to find guidelines, all the guidelines regarding one food item, you can also do this. But there are also, I have to say, there are also still a lot of possibilities to use ontology to manage the information of food-based guidelines. Here are just some example. And yes, so yes, and also here is a picture to show that through the link of the identifier of the ontology, we can reach the certain page of a certain page to get more information. And this would be also part of linked data if we use ontology to annotate the FO food-based dietary guidelines. And finally, we also like to give a attempt. I know it's really rubbish. It's just an attempt. If we use ontology to annotate this kinds of information, finally, we want to create a dashboard or kinds of way to visualize the information that we get from the text. So here you can see that in the picture, we can get the map to see the location of the area of the country who developed the ontology. And we can also some information, for instance, like the stakeholders, like the publication year, the publication frequency, etc., etc. So actually, this is all the things that we have done relevant to the food on the ontology and the NLP, the natural language processing. So by doing this, we hope in the future we can use ontology and yes, and other artificial intelligence technologies to make it to make make the food-based data get lengths more accessible. And yes, and here, and we also get some experience. For instance, once we use the ontology to annotate the food-based data get line, we saw there's still a shortage of our code, because if it's plural, it's hard for us to identify the food item. So here I would like to get your comments regarding our current achievement, and yes, it would be very helpful. And also, for instance, how to precise for instance, the terms which are plural or which are synonym of the of the ontology word, how to precise those kinds of words and make the programming better, make the annotation better. So yeah, that's the thing that I want to present during the meeting, and I'm looking forward to your comments and your suggestions. Thank you very much.
Great, thanks, Chen. That's really neat. I have a few comments, but let's open it up to other folks to comment on.
Okay.
Oh, I just want to say great work. I mean, awesome, really. It's really, really cool. And is it open for people to take a look at your dashboard and explore the data and whatnot?
I just shared the code on GitHub. To be honest, now I don't have the ability to run a dashboard online, but if you check the code, you can run it because I show everything. But yeah, I'm not able to develop a website and make it online accessible. But everything is online. I share all the code online. So
and
yeah,
that's interesting. So do you is that code all the way from the natural language processing and everything all the way through to the creation of the dashboard?
Sorry, can you repeat?
You said you used some Stanford natural language processing packages.
Yes.
And your GitHub code starts with the URLs for the dietary guidelines,
yes.
and it uses the Stanford packages. So your code goes all the way through from starting with the URLs all the way through to building a database and everything.
Yes.
Is that, wow, that's fantastic.
Yeah, so everything is automatic. There is no manual work inside. So that's from the URLs extracting information processed by the Stanford model, and also the food ontology to get the annotation, and then yes, they are all in the database now.
Oh goodness, wow. But you don't have a home for it, is that what you're saying?
Yes, I can only run the website by my computer. So it's I mean, because I'm not a programmer, to be honest. I think I'm a nutritionist. I'm a nutritional researcher. I learned programmer from zero. So this is currently what I can achieve. And if we really want to run it as a website, maybe I need to learn more, or maybe get assistance from other people.
Yeah, we'll totally help you with that.
Thank you.
That's fantastic. And what language did you write in? Python or?
Yes, I use Python.
Awesome. That's fantastic.
Thank you so much. Thank
you. So a couple of questions. So I'm sort of surprised that the NLP, I'm wondering about the NLP ability to recognize plurals, singular and plural. I know that's a problem generally in text mining, but so the Stanford NLP just doesn't have it can know that something is a verb or a noun, or but it can't figure out the plurality of nouns.
Yeah, and yes, and sometimes I don't know. For instance, for the food ontology, is that possible? For instance, we have like also include the plural as because currently, for instance, if I have if I want to identify the term like cereals, I found cereals because it's appeared many times in data get lines, but once I use Foodon to identify this, I found is that they only can identify like the singular version, and the plural version is not be able to be identified. So is there a solution, or there's something that we can do to process this by Fudong? I think it would be very helpful and help us identify more information. Is yeah.
Okay, so I can say on the food from our lab side, we were known as the Shao Lab, and now we're the Center for Infectious Disease Genomics and One Health. And in this lab transition, we sort of lost a server that housed the LexMapper software for mapping from free text descriptions to food-on terms, and it handled plural and singular conversion, at least to go see if there was a singular version of the plural term in food-on. So once we get that service going again, then I think that will be a solution to help with that stage of it.
Okay, nice, nice.
There's also Tome's group at the Slovenian
Tome. Okay.
Research Institute. I think he's doing that kind of stuff too.
Okay.
He could help on the machine learning matching of free text terms to food-on. Between the two of us, I hope to finally solve that one.
Okay, thank you so much. Thank you.
I'm curious if you've had feedback from FAO. I mean, are they interested? I know you guys, your work group sort of is in dialogue with FAO about how they're doing their dietary.
Yes, I still need to discuss with Carl and to see whether we should have a further discussion with the FAO, because currently it's it's a task from the European project, and the main purpose was not. Ooh, hello, can you hear me?
I can hear you, but the screen is a little jittery.
Sorry, I think that my internet was. Yeah, my internet was is not really stable. Sorry.
Okay.
Yeah, and yeah, but yeah, I think we should we could have a discussion with them. And currently, it's just a project task. It's not yet. We haven't discussed it with the FAO. Yeah.
Also, I'm kind of curious about what other work your lab has forecast in terms of dietary study documentation in the future. You folks added those terms into OBI to have study parts described. Do you have plans in the next year for working on that kind of stuff? Or?
Yes, I think it would be a very interesting stuff, and also I think because I think ontology is the thing to to annotate the language, the information other than the data. So to process the text, paragraph, papers would always my task. So yeah, if in case we have some other people who have interest in this, I think we can always achieve it, because yeah, although the ontology for nutritional epidemiology is the ontology for for the observational studies, for data service, but we are also eager to see how we can process other kinds of nutrition research, because they are always interact to each other, so they are always interlinked. So I would eager if we have some other people who want to work together with us, and yeah, and if you have we are also would like to contribute to other project if they found our tool useful or found our idea useful. Yeah, thank you.
Yeah. Other questions or comments from people?
This is Naomi.
Hello,
Sorry,
Naomi.
I had my hand up, but I guess you haven't seen it.
Oh, darn it.
But no, that's okay. It's very interesting. And so I have a very practical question in terms of how would you actually implement the use of this ontology in terms of connecting it to really what is in food that is reported in many of the observational studies that is usually trying to connect a single nutrient to health outcome. But how would you separate out that a tomato may not quite be the same thing as tomato paste, or, I guess tomato isn't good, or I guess we'll use apple, a raw apple versus an apple pie would deliver significantly different types of nutrient or bioactive profiles. So how would this help?
Well, so it's a question from me or it's a question for Danny?
No, it's for you, because you said you're a nutrition researcher, so I wondered
Okay.
how you were then planning to apply this for your area of research in nutritional epidemiology and connecting it to food composition.
Well, it's yeah, I think it's a very good question, and to be honest, yeah, it's also a difficult question. I think even I think currently for people, we still need to. Yeah, I think it's first of all, it's not a question about ontology. It's a question about human identification. So yeah, in our group, before we want to do this, we would have two to three researchers to do the identification or do the classification separately, and then to make agreement on this. So I think if we really want to make it as an automatic step to do this, first of all, we need to achieve the how to say it. We need to solve the problem manually. So maybe we can use the machine learning as a solution. Maybe if we have a lot of training data and we can make it as I don't know, because I'm not, to be honest, I'm not an expert in the field of machine learning, but I have some information from my colleagues, and they said if you use machine learning, you have a lot of data, and you can train the computer, train the model, and let the model to help you to classify different kind of words, which one is good, which one is incorrect, and to how to say, to calculate, to give a score to a set of terms, and to give a rank, and then you can choose which one that you can link to your ontology or to your graph, to your knowledge graph. So this could be a solution that, but I think the Slovenia group, Tomei, and yeah, they may have some better idea about this, and maybe other people here can also have to answer this question. That for me, this is a solution in my mind. First, we should solve the question manually, how to say, and then if we let those researchers to annotate a certain amount of data or information, and then later we can let machine to do this for us. So yeah, I hope I'm right.
No, I know it's a challenge, and that's why I asked the question, because I think that's what everyone is struggling with. That it's possible to take the use of computers and ontology and data sets to get you to a certain point. And I just wondered, I guess we still come back to the fact that you need a certain amount of manual human, true human input. Moreover, to generate the question, but really this enhances the ability to perhaps access information. Then putting it together still requires, the human.
If I could comment on that.
Yeah.
I Naomi, you're highlighting the need for a processing ontology, and the way I see it playing out is essentially that once we have a decent processing ontology, we can begin to compare samples. Let's just say your apple versus apple pie, and understand what temperature was that apple pie baked at. Or maybe we look at applesauce, or maybe we look at, and we realize, okay, look, when apples undergo a heat treatment above a certain temperature, maybe it's a certain type, maybe it's boiling, maybe it's broiling, maybe it's baking, I don't know, but But after we acquire enough samples to say, okay, look, when this happens, we know that we lose, X% of vitamin C from the processing of that apple. But once we have a processing ontology in place, and once we have some data that we can learn from relative to nutrient, I'm just going to say degradation, although perhaps you could be making nutrients by processing as well. But then we can begin to learn over these things. And so there'll be some amount of manual data, but I don't think any of this is going to happen until we have a decent processing ontology in place in order to define exactly how things were altered. Does that help at all?
Yes, thank you. I just, I'm asking it in a very naive fashion in terms I'm not really sure how to connect all the dots. But there is certainly a hell of a lot of potential. But the question is, which pieces of the puzzle do you put together first before you can achieve what we're all hoping to achieve?
Right.
So I have some comments. So on the wearing my infectious disease hat, one of the big projects this past spring was in the live review of various COVID papers and what the transmissibility basically is, that the semantics that the paper is talking about in terms of infectious disease transmissibility. What that requires is a model of viral and bacterial transmission. And every paper had something to say about that, whether it was studying characteristics of the virus or the environment within which the transmission was happening, or how to stop it. So the paper live review systems don't actually have a detailed model of infectious disease transmission. They're just trying to provide some lists of vocabulary for the who, what, where, when, how of epidemiology. But they don't have the model itself. So therefore, the curators, the manual curators, and the AI can't say, well, this paper is about this part of the model. It can only offer a bag of terms. And so one of our group's objectives is to create a more detailed model. So I agree with you entirely, Matthew, about the process model. And that's a great segue to, if I can, to give a little update on what the process model group has been doing. So can I do that now? I'll share screen and we'll take a look at that. So, Google Chrome, yes. No, not one. Which one?
So my next naive question: what do you mean by process? Do you mean the process of dealing with the food, or process of applying technology and ontology?
Right. So in the case of food, it's the transformations that occur.
The transformation. Okay.
And so we had been discussing this overall process diagram with let me get this in a screen form that can be used, is better for most people, which we've touched on in the past in this group, sort of a top-down biological, physicochemical, and planned process distinction. And so Tarini is doing great work in refining what the next levels down are in this. And ultimately, we're not trying to name every single process. That's an iterative process to add terms that mention specific processes. But what we want to be able to provide is a handbook of definitions and instructions about where one can place new terms and how best to define them with respect to whether they're primarily mechanical processes that have phenotypic outcomes, or if they are being used as part of some greater food process thing. So that group meets once every 2 weeks, and if folks are interested in helping out there, please join us. Now, the other aspect of this group is to figure out how to coordinate and possibly standardize or come to agreement within a couple of different projects in the food processing area. So the other folks we have on that group are Larissa Soldatova of the Exact2 laboratory process ontology, and Liana Ibenescu of the PO2 food process ontology that INRA has developed for industrial tracking of what happens to food in production. So the model comparison tab is a tab in this diagram which I can share out to people for viewing, and I'll give you guys the link right now in the sideboard if I can find it. I was wondering where the chat is. Here it is. Okay. So they're taking a look at Exact2, and there's actually, I think, a recorded presentation of the process meeting in which I go through how Exact2, which was created a number of years ago, looks at processes within the framework of a laboratory and the necessary ways of tracking exactly what's happening to substances there as they're combined and manipulated and heated. OBOFoundry has its general model of process, mainly developed by OBI, Ontology for Biomedical Investigations, and it provides for the vocabulary for talking about processes and sub-processes, the performers, the inputs and the outputs. But where it's a bit loose, where it isn't defined so well, is in adding time of all of these different things. So I'm making it my personal mission to see how the time ontology best fits into this. And then the PO2 process model relies on the time ontology and the sensor ontology to take a look at those industrial processing steps and describing with sensors what's happening along the assembly line. And their model basically has both the sampling process described as well as the sensory observation of the phenotypes that are occurring in the samples. And they're both looking at an assembly line of actual transformations to the food, which is sort of a third aspect or chain of processes actually that isn't mentioned here. So all of that's coming together to take a look at little examples of things like boiling. What is exactly happening in boiling? And you can put a name on the boiling process and offer a simple view that you're boiling something and that there are some side products. But the more you peel it open, the more complex it gets. And so ideally, we're looking at a process model that allows you to talk about things vaguely and in general, but also allows you to drill down and get into as many detailed sub-processes as necessary. So rifting off of Robert Warren's slide, and by the way, did I talk about this before to the whole group? Because if I did, then I'm repeating myself and my memory is shot. So mark me if I'm wrong. Have I actually talked about this in the monthly? Okay, nobody's saying yes, so I'm proceeding. So Robert Warren gave us a schema of so far how they're trying to capture the boiling of hops and mash. Or what do they call it? They call it musk, I think it was. as the beer making, as part of the beer making process. So the challenge really is to how to accurately describe that from an industrial processing or even home kitchen experience. So that is leading to this diagram, which is trying to capture the processes that are actually involved in boiling something. So you can be breaking these things down further and further into steps, such as adding liquid to a container, then being able to describe that some liquid is in a container, and then starting the boiling process. And then as intermediary stages, adding other things. And really, inside this complex model should be the simplification that enables you to talk about recipes and adding ingredients and formulations and specific times of intervening in a process, and the ability to measure things, whether it's in the kitchen, the temperature of the turkey, or what you're measuring out, and the times in precisely that these things are happening in. So this is trying to accommodate Warren's needs for processing and at a technical level, and as well the time ontology that PO2 is using. And it hasn't, and touching a little bit on the kind of measurements that from an OBOFoundry perspective, the way one would describe measurements, but OBOFoundry itself is awaiting sort of a standardization of that. OB has tried to offer ways in the past, but is awaiting kind of a final acceptance of particular ways to record these patterns of observation. So that's the update on this project. And comments from the larger group on this? What I can say is I'm going to try to write a little review paper that compares PO2, Exact2, and OBOFoundry ways in order to come up with a consensus process model going forward. And this is awaiting as well Matthew Lang's past work on all of the processes to be included in this hierarchy. So he's impressed us with his large hierarchy of food industry related processes, and we need to find homes where they fit. And his hierarchy points to distinctions about chemical or physical, mechanical, and biological, and phenotypes that result from all of that.
This is looking good, Damien. Can you go back to, you had a diagram of the container in boiling water.
Yeah.
So
I think this is the best.
Look, oh, nope, you were there. Oh, wait, adding liquid to container has input container.
Yeah.
Okay, so assuming there, that leaves a place for things like, what is the container made of? If it's is it a copper pot, a copper still? Will that, enable certain kinds of things, because of its material, the kinds of materials that are in it, what have you.
Right.
An iron skillet will put iron into my food, things like that. So I think that was just something that just jumped out at me looking at this. I can probably save these detailed comments for the food processing meeting, but I think that those are actually going to be important things.
Right. So that suggests, and you've immediately raised an interesting ontological modeling thing, and that's what this is all about. You know, we're trying to create these standards.
Yeah.
So the details of just describing this container are important to model out as well, as you just pointed out. Good point.
Yeah, actually, you know, taking it back to food guidelines. I mean, actually cooking things in an iron skillet is one way to improve the iron status of people who may not otherwise have iron in their diet.
Yeah. The other thing that this diagram is missing that I will expand out is the fact that it actually takes a while to heat up some liquid in some container. It just
Right.
it isn't instantly boiling. So this boiling process has disguised within it the ramp up, the heat up phase. And so we actually need a heating phase and a cooling phase as well. And Larissa Solatova would have recognized that right away. I don't know if she's on the call today, but so we actually need to bundle those processes. And especially at the industrial scale, you can be waiting for a big tank of water to heat up for an hour if it's big enough. So yeah. Note a couple of other things to note to try to accommodate the sophisticated needs of people. What we've got here is that all of these processes are mentioned by their temporal duration. And then process dependencies are also lined up with these relations that the relation ontology does have, such as ends with and immediately precedes. And if it's more convenient in your mind to switch that around, you can do that. Don't get hung up by the labels here, such as saying that this process immediately precedes a wait. Well, you can say that the wait is immediately preceded by, immediately follows, sorry, the adding solid to liquid, for example. So this is an example of a more sophisticated way to create dependency that's based on time within the processing of materials. And this is sanctioned by the RO relations ontology. So it's a capability that does exist in OBOFoundry, but it's not really well written up. These kinds of things are documented in academic papers here and there in the past 10, 15 years, but there's no manual for how to do it that's really public facing. So part of the objective, besides creating the model here, is to actually document it on the Foodon website.
Damien, I have a question here. So I see planned process, which seems to be different from, you know, natural sort of biochemical process and whatnot. Where would but something like ripening is a biological process and a chemical process. But what about planned ripening? How would someone model something like that?
Right. So let's go closer to home. Boiling is an ENVO term. And you can imagine boiling as just being defined as water at 100 degrees Celsius or something like that. Liquid at that stage, that phase between whatever the scientists call boiling, a gaseous and liquid state.
Mm-hmm.
What I would suggest we do is create subclass in Foodon anyway, boiling as a process that happens to a substance within a container. Some kind of dependence like that immediately invokes a more specific set of conditions and possibly materials. So that becomes a planned process, whereas boiling in the ENVO sense is not a planned process.
I see. Okay, so I see you're just modeling it right there in front of us. We're watching the Damien magic just happen right now.
Yeah, this is
Okay, right. So we're talking about being multi-homed is really what we're talking about.
Yeah, you would
Um,
infer that this somewhere in the axioms, this will say this is a boiling, so it would inherit all of the claims about what boiling is under atmospheric conditions and whatever. ENVO doesn't have any, so we're not actually getting much out of that. We might have to define it ourselves if ENVO isn't. If ENVO is trying to be really general about it, boiling can apply to ammonia, can apply to anything. And so we were more specific. Maybe we're just applying, saying that it has a necessary input, some water-based liquid, for example. That's enough to start straining.
I think that's actually too specific. I mean, we can boil alcohol, we can boil water.
Right.
Yeah, so, and those are very important distinctions.
Right.
So, okay, but this helps that there's, you know, this sort of multi-homing solution. Naomi, not to put you on the spot, but does this answer, or at least get at some of your questions earlier about sort of understanding how we can use this kind of model to approach the difference, say, between the nutrition of an apple versus the nutrition of an apple pie?
Yes, definitely. So, you know, then I was going to ask the next question is, since processing, you know, is done for multiple different purposes, some of which would be for food safety. And so I mean, I assume that you'll have a link to that at some point because certain codes have to be met, right? And if you do industrial processing to assure safety.
This has just been, Tarini just raised, and I kind of identified this difference of objective. So we were realizing that one sector of the diagram here could be separated out. So we've got all of these.
I can also speak to this.
Yeah, okay, yeah, you're there, good.
You could go on, Damien, it's fine.
Well, no, you go for it.
No, keep going. I don't want to interrupt you. I just want to say I'm there, so I can
Okay.
do this.
So we're well aware that a process by mechanism just says, here, we're doing this thing to this food or substance, and the substance will have an input sort of phenotype, hard, and then the output will be another phenotype, soft or mashed or what have you. That in itself we don't bundle in health effects or aims there. What we're then searching for is sort of a process hierarchy by health objective, and that is what I would call a concurrent process objective, in which there are certain phenotypic outcomes, such as low bacterial count, reduced water activity, that actually ride alongside whatever the mechanical or chemical or biological process was that's at work. So these are parallel objectives that we want to also be able to describe in terms of phenotypic effect. And then they naturally pair up and accompany the mechanical processes. And those mechanical processes may all be planned as well. Well, they are planned, yeah, here. So that the health effects can accompany the material transformations, but we're not trying to bundle them together. But the ideal ontology promises is that by reasoning, we can actually pair them up.
So I'll add a little bit more there on the safety aspect. So that might be quite specific to the microbial load, that if you reduce it by some order, then usually it's sort of like decimal fraction. So in a log scale, some reduction in the log scale gives you some food safety. And that really has to do, you could pasteurize something for food safety. And so we know that certain mechanisms, And pasteurization obviously is the combination of a certain temperature and duration and it varies for food substances. So the idea there, just to be able to limit the scope so that it is more comprehensive, the idea that I had started out with is a phenotypic transformation at a molecular level. So where certain biological, chemical, or physical properties get transformed, but this does not address the extent of transformation. And food safety definitely has to do with the extent, or at least, promising food safety has to do with the extent of transformation. And for that, maybe the process model, which describes more the dynamic of the process, is more relevant to that.
Okay, so the next, I'm sorry if I'm asking all these silly questions, but so then where does fermentation come in this? Do I see fermentation?
Yeah, fermentation is there. It is under transformation objective, and fermentation is where you are growing microbes. So
Yeah,
it
so
might be,
right.
yeah. So it might be a part of preservation, but then it has to have an additional step where you're doing something. You're either adding acidity or increasing salt concentration, where you're doing something so that it also destroys the microbes. So food fermentation here is more of a transformation objective, because the mechanism for fermentation could also be either doing it with yeast or doing it with bacteria. So the mechanism would be more about how you're doing it. Fermentation is, and I need to define this. Some of these, I've been working with all of these classes. I've been working to basically answer what is the phenotypic transformation. And I haven't done that yet for fermentation.
Yeah, and fermentation is a classic example of a planned process at one level, in that we're controlling the environment for that. So we need to add to this process those inputs in the context that occurs, that controlled event occurs under. And then we also want to be able to describe fermentation without, as though we're a natural process that unfolds without any of these interventions, such as under a certain temperature and controlled temperature.
I think, yeah, I mean, so, generally when we think about fermentation in sort of common parlance, we can use it in two different ways. In one way, we can just say, oh, my compost pile is fermenting, and whether it's, we can even define the certain types of fermentation, but more specifically, when we talk about fermentation, I'm fermenting this beer or this champagne or this. What we're talking about is not just a generalized fermentation of a bunch of microbes that are growing, but a selective fermentation of the specific organisms that we want to grow. And sometimes that's started by a specific inoculant, and sometimes that is started by specific conditions that we know are favorable to that specific microbe. And the hope is, in that process, that microbe will grow under those specific conditions and outcompete the bad guys who may be toxic or deleterious in some way, like flavor or texture or something like that. So so it is, but I think that somewhere there needs to be a distinction that the fermentation is selectively fermenting specific microorganisms.
This actually reminds me.
In the process by mechanism, there is a mechanism by chemical And no, actually, there's a mechanism by food modification by microbe addition. So there is basically the starting of that to accommodate how that could be controlled, and you could selectively add a certain kind of microbe. Again, Matthew, talking about a lot of dynamics where you're like actually understanding substrates, you're understanding reaction mechanisms. And the idea is not to fit all that into, it wouldn't be the place in the process ontology, but the fact that it can be planned, that's definitely there.
Well, yeah, I'm thinking actually I wasn't going quite as deep as what you just said there. What I was thinking was something akin to if I am, for instance, pickling peppers, I can just add some salt to my peppers from the garden, and then I can promote the growth of certain varieties of lactic acid bacteria that are naturally on the pepper, right? And this happens with wine too, where we just create conditions that favor the growth of the microorganisms that we want. Certainly, we could inoculate with the organisms we want, but oftentimes we don't need an inoculant. All we need to do is present the favorable conditions for the bacteria that are naturally on the food itself.
So this is totally reminding me, and Duccio's comment as well in the chat, is that ONS was actually, the ONS team is doing fermentation as another objective within ONS, I think funded, basically allowing them to go in that direction. So Duccio, do you have a comment about that? We should be liaising with you about this this fermentation model, or handing it to you.
No, thank you. No, in fact, this is a relevant point for two reasons. First of all, fermentation is correctly next to the food preservation actions, and it's part of these ontologies. It's important for food preservation by itself. Fermentation produces a lot of the food preservatives. If you think about acidification, acetic acid is one of the main stabilizers that's added in pickles. It's added everywhere, but originally it's produced by acidic bacteria that, transformed ethanol, if you're talking about alcoholic fermentation or other processes. So yes, you're right. Into the ontology for nutritional science, we're trying to define precisely the origin of the microbes that are involved into the fermentation processes, into the different, let's say, products. We have taken as an example Parmesan cheese, that it's an interesting example because Parmesan cheese sees several bacteria and the biotransformation of fermenting products during the ripening of Parmesan. And at the same time, we're also looking at kefir, that it's another example of fermentation that sees yeast and lactic acid bacteria that are collaborating together to the end point of the product. So yeah, it would be nice. I mean, we can indeed contribute to this section, and we have been working on it. And as Matthew was saying, I think one of the key things that discriminates, this is a very complex point, but the main point is whether the microbes performing the fermentation are originated from the food. So if they are part of the food components, if they arrive with the plants, if they arrive with the grapes, they arrive with the prickles, and this is sort of, I would say, traditional production method. It's often present in traditional foods, but in modern foods, all the fermented, the actors of the fermentation are added during the food production process, and they have been selected for specific for specific tasks. So yes, there are some natural starters and that involve, I would say, non-globalized food productions. I would say probably traditional food productions, part of regional cuisine. And then there are a number of selected starters that are often universal throughout the world. We can see food globalization also as a globalization of the starters. Just to give you an example, wine, the yeast is used in wine production in the entire world, less than 10. So there are 10 Saccharomyces cerevisiae that ferment all the wine from Bordeaux region to Chile. And the yeast used in bread production, and I'm talking about the industrial ones, are two. There are two strains used worldwide. And this is one of them actually has been selected here in Florence, Tuscany, by since a couple of 100 years ago. So no, 120 years ago, sorry, the time of Louis Pasteur, basically was the time where they were isolating the first bread fermenting yeast strains. And so what I'm saying, I think it's an important section. If you want, yes, we can take care of integrating what we have done in this piece of work.
Excellent.
I think
just a quick question: is the Duccio, is your group going to be ready to sort of present about what you've been doing in the fall?
Yes, we are going to be ready. I have a deadline for my folks to arrive to a couple of to get some finalized sections by June the 20th. So, I mean, I'm expecting to have all the cheese fermentation, the kefir fermentation, and some other, and ready by the mid-June. So June 15 is the deadline for the people in my group. So we will be ready for that.
Okay, great. Thanks. Okay, Matthew.
Yeah, Duccio, I just have a question for you. I mean, well, you mentioned that more industrialized or globalized foods have the inoculant, presented, and not just naturally, but sort of forced into the situation, sort of what we might call a forced fermentation. And then I would go one step further and say sort of the ultra processed type things, like what 99% of North Americans will find in the pickle jar is not something that was actually fermented, but something that just had acetic acid added to the vegetable, and they call that a pickle. And that's, to your point, that serves the safety purpose by reducing the pH, which normally be done by fermenting organisms, sort of traditionally. And in fact, I think probably most Americans have never tasted a proper pickle, which leads me to this idea that what you're talking about is not only important for food safety, these same processes are going to be critical for establishing things like protected denomination of origin, which is something in Italy where and in the EU, where these traditional methods are essentially codified by law, and being able to model those kinds of things so that we can really valorize these traditional methods, I think is going to be hugely important when we talk about utilizing technology for essentially the democratization of food systems and the valuation of traditional methods.
Thank you, Matthew. I mean, it's I'm very glad that we think along the same lines. Actually, I'm actually writing some sort of position paper, and I'll be glad to expose it to you, because it's not something that should be part of one or two people, but it would be important. I think that a lot of the food globalization, what we call westernized foods, there is not a proper definition. We're also trying to work on that definition. And in our opinion, a lot of that comes from the standardization of the fermentation processes and the fact that the preservation of foods is achieved mainly not through fermentation of leaf stalks, but by adding, secondary metabolites to stabilize the food. And that's exactly what you're saying, but it goes as far as sausages. I mean, because if you see the meat fermentation is very similar to that. Currently, sausages and meat fermentation is not really happening because they're not fermenting the meat. We're just adding preservatives, while traditionally meat from sausages to Würstel, to whatever, the Bratwurst or whatever, even in the German tradition, that meat was fermented. Currently, we're adding the stabilizing things. So I think it's within an important point on the definition of what is a westernized, diet, the westernized food. I was counting several hundred papers that are currently talking about food globalization, but they're not defining this concept at all. It seems to be supermarket. It arrives before the supermarket.
So that would be a fascinating paper.
That would be.
Yeah, it would be excellent to point that out in terms of, we call it the same process, but yet the intent is slightly different, or the methodology.
Correct.
Well, not just the intent, right? And I think that's you're making. You started down an important path there, Naomi, but there and I just want to crystallize something that Duccio was saying, and that is that in our rush to industrialize the safety of food, so that we can achieve economies of scale and mass produce things, centralized processing, centralized food production. What we've lost is we've taken what we see as the key ingredients that are produced, the secondary metabolites that Duccio mentioned, that result in preservation, but we've lost all of these other metabolites that provide flavor, that provide health benefits, that provide all of these other bioactivities, and we don't even know what they do. And now, because we've prioritized this food safety issue, which of course we should, sorry about the noise, we've missed out on a whole ton of information. And so, this ontological approach, I think, gives us the ability to open that window and see again what it is that's there, and to value it properly.
Yeah. Yeah, that's a good point. Something to distill and work on. Because I think that's the kind of clarity, or at least distinctions and discussions that are extremely important to bring up at this point in time, given the globalization of the food system, as well as attempted changes in how to produce food, to be sustainable as well as healthy and safe.
Correct.
Yeah, and the rediscovery of the foodie, the whole momentum of the foodie movement is to value food a lot more. So that fits well.
And just sort of, there are going to be several gotchas along the way, and I'll just give one example. If you look at something like traditional balsamic vinegar, which has its own protected denomination of origin, the specifications behind the PDO for traditional balsamic vinegar is that it needs to be fermented in the attic of a roof of a house in Modena, Italy. so it has to be at least a 2-story house, and it has to be in the attic. So then one wonders, well, what is the point of these things, and how do we?
Maggie says the aroma of the town.
I have an even better example that it's.
Oh, great!
I don't know if if you have ever heard this is a very special food. Actually, when I was, it was forbidden transported to the US when I was working in the US a long time ago. There was a club that among the Italians that were working abroad, and it was like the Lardo di Colonnata Club is the Colonnata lard. Colonnata lard is fermented. It's fat fermented into Carrara, into the marble. So the way it's fermented is put it into these marble containers covered with laurel and with the flavoring things, and then they leave it to ferment there in the same place where Michelangelo used to dig these stones for the monuments. It's an unbelievable thing. It was forbidden by the European Union because it was not considered to be food safe, and it was the export to the United States was forbidden in time. So, I mean, the scientists abroad were saying it's better to eat lardo di colonnata, that it's something very special for Tuscans. We use it in several of our dishes, or like to make good science. And it was a very relevant question at the time, Matthew. No, I mean, but you're right. So I do think it's really, so there was juniper, it was laurel, rosemary, and this lard, and it didn't taste at all like lard. I mean, the flavor was unbelievable. And all the secondary metabolites were due to the extraction of the flavoring molecules done by probably fermenting bacteria, and everything was related to the presence of the food components. I think that microbes make receipts often, and if you don't use the microbes and use the preservative, you lose the most of it. You know, from a Tuscan point of view.
Wow. Well, I love that story, and I want to taste it now with a fervor. Any other comments before we wrap this session? It's been a great session. Love this.
Yeah, I want to throw one more example out there because I think it might have an impact for how we think about actually going about modeling fermentation. And so I'll give two examples, and they're both related to cheese. And Duccio is probably familiar with both of them. And they both have impacts on food safety. Now, these two cheeses are both food safe, but they're not recognized by the FDA as being food safe because methods are not recognized. So one is mimolette. It's a French cheese. And there are small, very tiny, almost microscopic mites that are on the outside of the cheese. And they consume the rind of the cheese. And then the bacteria inside the gut of the mites essentially ferment that rind. And then the mites, essentially poop out wonderful bioactives that then get into the cheese. So the cheese becomes, it's a secondary fermentation as a result of being, put air quotes around, infested with mites. The second one is a Sardinian cheese that is the organ, pardon me?
Caso Marzu.
Yeah, Casu Marzu. See, see, yeah, it's where you essentially have maggots eating the cheese, and it's the organisms inside the maggots that are fermenting the cheese and enabling its preservation, and so there the fermentation containers, the fermentation vessels, part of it, are the guts of these insects. And I think, when we start thinking about fermentations, we have to really open our minds up and think like, wow, like what do we mean when we talk about a vessel? It's not just putting it in a pot or something like that.
Great.
Hande says mimolette is Dutch. Yeah, I don't know about that. She's going to get some kickback from the French here in a second. We're going to have a little food war in the participants' comments.
Yes, well, I do agree that being part of the food ontology community involves talking yourself into eating just about anything at least once. So, yeah. Okay, thank you, folks. It's been a wonderful session, and look forward to next month's. And we'll try to follow up where necessary with ONS in terms of the fermentation. I guess my question I will leave with you, Jucho, is which terms for this fermentation discussion should sit in ONS, and which other ontologies should they be moved out to?
I will make sure that that the group is there to discuss this, and we have already a few proposals. So it would be quite. I mean, it's quite relevant, and then we can continue this discussion with Francesco. That's working on this specifically.
Okay,
so, very
great.
good. We'll be there.
All right, thanks everybody, and talk to you next month.
Bye-bye.
Bye.
Thanks, Damien.
Bye, Matthew. Bye.
Bye.
Bye.